So the topic which we are going to start today is the conductance of electricity through the electrolytic solutions. Okay. So first of all, before going to the topic, we will see that conductors. Okay, conductors. So I think you're familiar with this word conductors. Okay. So conductors generally they are of two types. Okay, so one is the metallic conductors and another one is the electrolytic conductors. Now conductors are those substances no which allow the passage of electricity through them very easily. Okay, conductors ऐसे substances होते हैं जो कि इलेक्ट्रिसिटी को पास करने का या फ्लो करने का वर्ड प्रॉपर्टी जो है प्रोवाइड करता है. ठीक है, इलेक्ट्रिसिटी पास हो सकता है उसके थ्रू, जिस भी सब्सटेंस के थ्रू, उसको हम लोग क्या बोलते हैं, कंडक्टर्स. एग्जांपल ले सकते हो मेटल्स. ठीक है ना, मेटल्स के थ्रू से इलेक्ट्रिसिटी इजीली कंडक्ट हो सकता है, फ्लो कर सकता है, राइट. सो इट कम्स अंडर कंडक्टर. सिमिलरली देयर इज अ वर्ड कॉल्ड इंसुलेटर. सो इंसुलेटर दे डू नॉट अलाउ द passage of electricity through them, and hence they are what, non-conductors. They are called as non-conductors. Example may be wood, plastic, all that. Okay, so now we are coming to the topic, the metallic conductor. Now metallic conductors, they are also known as the electronic conductors. Okay, electronic conductor. And in this case, the in the metallic conductors, the mainly the current which is generated, okay, it is because of the flow of the free electrons. Okay, it is because of the flow of the free electrons. When these free electrons they flow through these type of conductors, right, in the presence of the applied voltage, what happens, the electricity is generated. So due to the passage of, or due to the flow of the free electrons through the metals, because we know that metals they are composed of what, metals they are composed of atoms, right. मेटल्स एटम से बना होता है, और एटम्स के अंदर में क्या होता है, इलेक्ट्रॉन्स होता है जो कि चार्ज्ड होता है, राइट. सो इलेक्ट्रॉन चार्ज होने के कारण व्हेनेवर वी अप्लाई अ पोटेंशियल डिफरेंस, इट स्टार्ट्स फ्लोइंग, and when it starts flowing it conducts electricity, and this comes under the category of electronic conductor or metallic conductor. Now this is different, this is the electrolytic conductors. Okay, in case of electrolytic conductors, now what are electrolytes first of all? Okay, so electrolytes are those species or those substances, say NaCl, okay, which on dissolving in water, जब हम लोग उसको water में dissolve करेंगे तो क्या होगा, इट विल प्रोड्यूस आयंस. ओके, वाटर में डिजोल्व करने से ये प्रोड्यूस क्या करता है, आयंस प्रोड्यूस करता है, एंड दैट आयंस आर रेस्पॉन्सिबल फॉर द कंडक्शन ऑफ इलेक्ट्रिसिटी. ओके, सो दैट मीन्स इन केस ऑफ इलेक्ट्रोलाइटिक कंडक्टर्स, हु आर द चार्ज कैरियर्स, इट इज द आयंस. ओके, the ions or the positive ions, maybe the negative ions, they are the what, they are responsible for the conduction of electricity. Okay, so here the free electrons and here the ions. So like example, you have NaCl, right. In NaCl, when it dissolve in water, it will produce Na positive ion and Cl negative ion, and hence we know that the NaCl solution, it conducts electricity, right. And here the example is the what, metals, right, metals. It may be copper, right. So now this is clear what is the electrolytic conductor and metallic. The main difference is what, here the charge carriers are the ions. The current is produced due to the ions, because these ions flow, right, in when potential difference is applied, these ions, what, these ions move, they have ability to move, right. And these free electrons here conduct the electricity. So likewise. Okay, so now here in this very chapter we are going to learn about these electrolytic, okay, the conductance of the electrolytic solutions. These electrolytic solutions, how does it conduct electricity? So we are going to learn in this chapter about these electrolyte. Okay, so now first of all defining, before going to these conductance, okay, topic. So first of all some terms may be defined. Okay, should be defined, should be known to you. So कुछ terms है जैसे कि resistance. Now resistance क्या होता है और conductance क्या होता है, ठीक है. So see, this is the ability, right, the ease or ability through by which current flows through the substance is known as the conductance. Okay, क्या होता है? It is the ease, okay, or the ability by which current flows through the substance. किसी भी सब्सटेंस का एबिलिटी, ठीक है, किसी भी सब्सटेंस का एबिलिटी या इलेक्ट्रोलाइट ऑल्सो, बिकॉज हियर इन दिस टॉपिक वी आर गोइंग टू टॉक अबाउट द इलेक्ट्रोलाइट, तो किसी भी सब्सटेंस का एबिलिटी या फिर उसका ईज, ठीक है, कि वो कितने अच्छे तरह से अपने से मीन्स थ्रू देम इट इज अलाउिंग टू पास इलेक्ट्रिसिटी. सपोज a copper wire, we know that the copper wire can conduct electricity, right? It is a conductor. Now with what ability, or with how easily this copper wire can allow the passage of the electrons through them, okay, or in other words allow the passage of the current through them. It's what conductance. We will say that the conductance is more or less like that, okay. So conductance is nothing but it is the property or the ability by which the current flows through the substance or the electrolyte, okay. Now one more word is there, which is the resistance, okay. So when we talk about conductance, we have to talk about resistance, because what happens, students, you see, some factors are there, like temperature is there, okay. So what happens when these temperature, it affects the conductance, okay. So when this temperature increases, what happens, the electrons which are flowing through the substance, through the conductor, they undergo collisions, okay. मतलब जब इलेक्ट्रॉन्स फ्लो करता है कंडक्टर से, ठीक है, तो क्या होता है, टेम्परेचर एक फैक्टर है जो कि कंडक्टेंस का इफेक्ट करता है. सो जो कॉलिजन्स होता है, मतलब इलेक्ट्रॉन्स एक दूसरे के साथ में टकराते हैं, व्हेन दे फ्लो they undergo collisions, okay, because there are many electrons, there are many atoms in a metal, right? So what they happen, they collide, and once they collide, what happens, the speed with which it was flowing, it gets restricted, okay. Once the speed gets restricted, what happens, the conductance value drops, right? Obviously अगर इलेक्ट्रॉन का फ्लो से ही इलेक्ट्रिसिटी जनरेट हो रहा है, और इलेक्ट्रॉन का फ्लो को अगर स्पीड को हम लोग कम कर दे किसी भी रीजन से, वो टेम्परेचर हो सकता है, तो क्या होगा, ऑब्वियसली कंडक्टेंस का वैल्यू क्या हो जाएगा, कम हो जाएगा, करंट फ्लो करना कम होगा, right? So this is the what, these property is known as the resistance. It is the what, it is mainly the opposing force, right? You can say it is the mainly the opposing force which what, which slows down the flow of the electrons, right? Which slows down the flow of the electrons, and hence what happens, the conductance, it decreases, okay. The conductance of the substance, it gets decreases, and the factor may be like temperature increase होने से collision बढ़ता है इलेक्ट्रॉन के बीच में, एटम्स के बीच में, एंड इस वजह से भी क्या होता है, रेजिस्टेंस ऑफर होता है, और जितना ज़्यादा रेजिस्टेंस ऑफर होगा एक कंडक्टर को, इतना ही कम कंडक्टेंस होगा. सो दीज टू आर इन्वर्सली रिलेटेड, ओके. रेजिस्टेंस अगर ज़्यादा है, ठीक है, रेजिस्टेंस अगर ज़्यादा है, कंडक्टेंस क्या होगा, कम होगा, एंड इफ रेजिस्टेंस इज लेस, द कंडक्टेंस इज मोर, ओके. So that means we can write like this, that the conductance G, it is represented by G, and resistance is represented by R. So the conductance is equal to 1 by R, like this we can write, okay. That means that if more resistance is present in a conductor, okay, or in a substance, the conductance value will be less, okay. It will conduct less if the resistance is more, right? Now what is the unit of resistance? The unit of resistance is what, ohm, okay. Ohm, we represent ohm like this also, okay. See, these about resistance, no, in the Ohm's law you may have heard, Ohm's law was like this, like V by I, where V is the potential difference, I is the current, okay. So for carrying 1 amp resistance, the definition was like this technically, that for carrying 1 ampere of current, this is current, right? For carrying 1 ampere of current, how many volts are required? What is the voltage required? If the voltage required is 500 volt, that means you can say this, the resistance is 500 ohm, right? So for carrying 1 ampere of current through any substance, what is the voltage required, right? And that is known as the resistance of the substance. So if voltage is 500 volt required to carry 1 ampere current, so your resistance will come out to be 500 ohm. So you have learned this in detail in the Ohm's law in physics, right? So here this is the unit of resistance is ohm, and similarly if ohm is the unit of resistance, the conductance unit will be what? The conductance unit will be, you put here G equal to 1 by R, so 1 by ohm, so 1 by ohm means what? Ohm inverse. So the unit of conductance is ohm inverse. Okay, ohm inverse. And ohm inverse is also known as Simon. Ohm inverse is also known as Simon. You have to remember capital S. So this is the SI unit. So ohm inverse is also known as Simon, capital S. Now, one thing you sometimes you may have come across, like the resistance of any substance, no? The resistance of any substance is directly proportional to the length of the length of that substance, and it is inversely proportional to the area of cross section of that substance. So we are talking about a wire or a metal conductor, right? So this is the length of the wire, right? And this is the area of cross section of the wire, right? So the resistance is directly proportional to the length of the substance. Means what? If length is more, ठीक है, लेंथ अगर बड़ा है, so इलेक्ट्रॉन्स फ्लो का जो पाथ होगा, राइट, ये भी बड़ा होगा, लंबा होगा, राइट। जितना बड़ा वायर होगा इतना ही तुमको इलेक्ट्रॉन फ्लो करेगा, मतलब इलेक्ट्रॉन का पाथ क्या हो जाएगा? बड़ा हो जाएगा। एंड इफ द इलेक्ट्रॉन पाथ इज लॉन्गर, इट इन इट्स पाथ इट विल अंडरगो मोर कॉलिजन्स। अगर इलेक्ट्रॉन का पाथ लंबा हो जाता है तो वो कॉलिजन्स ज़्यादा मिलेगा उसको, और कॉलिजन ज़्यादा होने का मतलब है रेजिस्टेंस ज़्यादा होगा, ठीक है। सो दैट मीन्स इफ लेंथ इज मोर द रेजिस्टेंस इज मोर, राइट। एंड एरिया, अगर एरिया छोटा होगा, ठीक है, इफ कम एरिया होगा तो क्या होगा कि इलेक्ट्रॉन्स को ज़्यादा क्या होगा? ऑपोजिशन मिलेगा। मीन्स इलेक्ट्रॉन्स एक दूसरे के साथ में टकराएंगे ज़्यादा, राइट। इलेक्ट्रॉन्स विल अंडरगो कोलिजन मोर बिकॉज द एरिया इज लेस। एरिया कम है, छोटा है, ठीक है, जगह छोटा होने से इलेक्ट्रॉन्स को ज़्यादा ऑपोजिशन होगा, ज़्यादा कोलिजन होगा। सो हेंस व्हाट विल हैपन? रेजिस्टेंस विल इंक्रीज। सो इफ एरिया इज लेस, रेजिस्टेंस इज मोर। इफ एरिया इज मोर, so resistance will be less automatic. Now if we combine these two expressions, so what will happen? R will be directly proportional to length upon area. Length you can represent by L, area you can represent by A, right? So L by A, right? And if we remove this proportionality sign, we get R equal to rho L by A. So this is rho, okay? This way pronounce it like this, rho, okay? So this is R equal to rho L by A, and this rho, no, this rho is known as the resistivity of a substance. Resistivity or specific resistance. Resistivity or specific resistance, okay? Now if we want to define this resistivity or specific resistance, how can we define that? So you just find out the expression. So now we will talk about the what? Resistivity, or mainly we will use the word resistivity and not specific resistance, okay? The IUPAC, it recommends the use of resistivity instead of specific resistance. Now from here, if we want to find out the expression for rho, how can we do? Rho equal to R into A by L. Just the cross multiply you do. So rho will be equal to what? R into A by L, right? Now if I put this value of A as 1 centimeter square or 1 meter square, right? If the area of cross section, say this area is 1 centimeter square, and the length of the wire or the conductor is 1 centimeter or 1 meter, so what will happen to the rho? Rho will be equal to R, obviously, because this is 1 in 1. So rho will be equal to what? R. Now how can you define this specific resistance? So specific resistance or resistivity is the resistance, okay? It is the resistance offered by a substance, okay, to the flow of current when the area of cross section is 1 centimeter square and the length of the substance is 1 centimeter. Okay, so like this we can define the resistivity. So it is nothing but it is the resistance offered by a substance when the area of cross section is 1 centimeter square and the length is 1 centimeter. Now if we want to write the unit, so what will be the unit? Unit will be what? You take this one, R. So what is the unit of R? It is ohm. What is the unit of area? Area is what? Centimeter square. And what is length? Length is centimeter, right? So this is gone. So it will come out to be ohm centimeter, or we can also write like this, ohm centimeter, or if we take the units in meter, we can write what? Ohm meter. So this is the unit of what? Resistivity. This is the unit of resistivity. It is ohm centimeter, ohm or ohm meter, right? So this is all about the resistivity or the specific resistance. Now one more term again you will get is the what? Conductivity or specific conductance. Conductivity or specific conductance. So mainly we will use this term conductivity, right, instead of specific conductance, and represented by a symbol K, right, and this is known as the kappa, right, kappa. So conductivity or specific conductance, it is denoted by this kappa, right. Now it is nothing but the specific conductance or conductivity kappa, it is equal to the what? It is reciprocal of resistivity. It is the reciprocal of resistivity, right? Resistivity. Now you take this expression of resistivity, this one, and you just substitute here. Okay, what you will get, you just see. So kappa equal to 1 by, instead of rho we will write this expression, right? So R into A by L. Okay, now it will be equal to what? 1 by R into L by A, right? This is. Now this 1 by R, already have said you that this 1 by R is nothing but it is what? Conductance G, right? So we will put here, right? We will put here. So instead of 1 by R, we can write what? G, which is the what? Which is the conductance of the substance. And this L by A, no? This L by A is known as the cell constant. This L by A is known as the cell constant. I'll talk about it later on, right? So this is the cell constant and it is fixed for a cell. If we are talking about a substance, it will be fixed, because you see, if this is the substance we are talking about, so the length will not change, right? And the area will also not change once it is taken. So this will not change, right? And hence it is known as the constant, and it is known as the cell constant, right? And this is the nothing but this is the conductance, right? That means this conductivity is equal to what? Conductance into the cell constant, and this conductance is nothing but it is what? 1 by R, the reciprocal of resistance, just now we discussed, right? So ये हो गया conductivity. Conductivity क्या है? Conductance into सेल कांस्टेंट. सेल कांस्टेंट किसी भी सेल के लिए फिक्स्ड होता है, क्योंकि लेंथ और एरिया तो चेंज नहीं होने वाला है once you take the substance, right, cell. And conductance, we can measure it. How we will measure? We will take out the resistance, and this is taken out how? We can easily do it by the Wheatstone bridge principle. You may have heard in physics. If not learned, you will learn Wheatstone bridge principle. So with using this principle, we can find out the resistance of any substance, any cell. Okay, once we find out the resistance, and we will obviously know the length and area, because whatever cell we will take, whatever substance we will take, the length and area will be known, right? Once we substitute all the values, we can find out the conductivity easily. So likewise, we can find out the conductivity of any cell easily. Now if we want to define, what will happen, what will we do? Conductivity, if we want to define, so length we will take it as 1 centimeter, say. Area we take it as 1 centimeter square. Okay, Now, so what will happen? So conductivity will be equal to what? Conductance G, right? Conductance. Once we take the length of the substance to be 1 centimeter, area to be 1 centimeter square, so the conductivity will come out to be the conductance. So how can we define it? So the conductivity is the conductance. It is the conductance of a material having length of unit or length 1 centimeter and unit area of cross section, because we have taken length equal to 1 centimeter and area equal to 1 centimeter square. So conductivity is the conductance offered, or the conductance which is offered to a material, okay? Conductance having, so the material having the length 1 centimeter and area of cross section also equal to 1 centimeter square, right? Now what will be the unit? The unit of kappa, it is also very important. See, units are very important. So we will take this expression, right? So kappa equal to conductance into L by A. Kappa equal to conductance is nothing but 1 by R into L by A. Now what is 1 by R? So you write how to find out the unit. So this is ohm, L is centimeter square, right? So ultimately you will get what? Ohm inverse centimeter inverse, okay? And if you take in meter, it will be ohm inverse meter inverse, and already I have said you that ohm inverse is nothing but it is Simon, so it will be Simon centimeter inverse or Simon meter inverse, okay? So these are the units of these kappa. Based upon this, if you take centimeter, it will come out in centimeter, and if you take in meter, it will be meter. So either you can write ohm inverse or you can take Simon, okay? So this is the unit of what? The conductivity. So the units you have to see, okay? Now one thing, so here already I have said you when I started that we are going to talk about the what? Electrolytic solutions, not the material, not the metal, right? The electrolytic solution. Then in case of that, what will be the conductivity, right? So here I'll just show you. Say one cell is there, okay? One cell is there. This is the cell, okay? And this part and this part of the cell, both the opposite parts of the cell, these are the electrodes, okay? These are the what? Electrodes, metal electrodes, right? These are the what? Electrodes, the metal electrodes, okay? And they are connected to a battery, right? They're connected to a battery, and the length between the two conductors, this is one electrode, this is another electrode, because we know in a cell if we want to talk we have to take electrode. So these are the two electrodes, right? And the length between the two electrodes is, you have to imagine, it is say L, and we are taking it to be as 1 centimeter as of now, right? And the area of cross section, because the electrode will have some thickness, some area will be there, right? Both. So the area of cross section is taken as to be 1 centimeter square, okay? 1 centimeter square. Now the electrolyte here, right? So once we are taking these electrodes, right, we are connected to the battery, we have taken the length and the area is 1 centimeter and 1 centimeter square respectively. Now there will be some electrolyte present here, right, because we are talking about a cell. So say, so what will happen, these electrolyte, the volume which this electrolyte is occupying will be what? Will be equal to what? 1 centimeter cube, right? So the volume of the, say we are taking electrolyte, any electrolyte you just take, say KCl we have taken, right? So the electrolyte which is present in this very volume, because these are the electrolytes, these two, right? And this gap is there, no? So here some electrolyte will be filled, okay? Some electrolyte will be filled, and the volume, it will occupy some kind of volume, right? So volume of these electrolyte will be 1 centimeter cube, because the length is 1 centimeter, area is 1 centimeter square. So the volume क्या होगा? 1 centimeter cube होगा. अभी इसका, ये सेल का अगर तुम लोग कंडक्टेंस निकालोगे, ठीक है, कंडक्टेंस कैसे निकलेगा? कंडक्टेंस निकालने के लिए रेजिस्टेंस निकालना पड़ेगा, और रेजिस्टेंस कैसे निकाल सकते हैं हम लोग? व्हिटस्टोन ब्रिज को यूज करके. सो रेजिस्टेंस हम लोग का निकल जाएगा व्हिटस्टोन ब्रिज का प्रिंसिपल से, ठीक है. अननोन रेजिस्टेंस होता है कुछ, ठीक है, और जो और नॉन रेजिस्टेंस होता है, तो विद द हेल्प ऑफ नॉन रेजिस्टेंस वी कैन फाइंड आउट द अननोन रेजिस्टेंस. व्हिटस्टोन ब्रिज प्रिंसिपल, यू गो एंड सी, you will understand. Now one more thing is written needed, which is the cell constant. How do we find the cell constant? Cell constant तो already known होगा एक सेल के लिए, ठीक है ना, ऑलरेडी बताया मैंने. अगर एक सेल तुम लोग कंस्ट्रक्ट करोगे तो उसका लेंथ और एरिया तो ऑब्वियसली खुद को पता होगा. So that means L by A is also known to us. Now when we know the L by A, when we know the resistance, that means we can find out the conductance. This conductance is known as the conductivity. Whatever conductance will come out will be known as the conductivity. That means इससे क्या पता चलता है, और एक डेफिनेशन क्या मिला कंडक्टिविटी का, कि कंडक्टिविटी का डेफिनेशन क्या मिला कि 1 सेंटीमीटर क्यूब या 1 ml अगर हम लोग इलेक्ट्रोलाइट लेते हैं, ठीक है, 1 ml या 1 सेंटीमीटर क्यूब इलेक्ट्रोलाइट का जो कंडक्टेंस आएगा उसको हम लोग कंडक्टिविटी बोलते हैं. So specifically the specific conductance or conductivity, it is the conductance of 1 centimeter cube volume of an electrolyte when the length of the cell is 1 centimeter and the area is 1 centimeter square. ठीक है. So ये हो गया एक और definition for this conductivity. Okay. So in short you can just write down that this conductivity, it is the conductance of 1 centimeter cube of the solution of an electrolyte. So this is in the one definition, another definition of conductivity. So this concept is very very important, that what exactly is specific conductance or conductivity. Okay, so this will be required in the later on, right? So this you should know that exactly 1 centimeter cube solution अगर है उसी का conductance को हम लोग क्या बोलते हैं? Specific conductance or conductivity. Now there is a type, okay, there is a type for this conductivity, and it is the molar conductivity. One more is there, but in your syllabus only this type is given, the molar conductivity, and not the equivalent conductivity. So what happens, no, that yes, what happens that when we talk about electrolytes, okay, when we talk about electrolytes, so like in metals, metallic conductor or electronic, which I said, so there you can just find out the conductivity, no problem. But when we talk about the electrolyte, जब हम लोग एक electrolyte का बात करते हैं तो electrolyte में क्या आ जाता है consideration में? Volume electrolyte का आ जाता है, क्योंकि we know that electrolyte तो किसी solvent में dissolve करोगे ना, लेकिन मेटल के केस में तो वैसा कोई बात नहीं है, ठीक है. तो इलेक्ट्रोलाइट का जब हम लोग बात करते हैं वॉल्यूम आ जाता है, ठीक है, वॉल्यूम जिसमें हम लोग इलेक्ट्रोलाइट को डिसॉल्व करेंगे, राइट. सो इस वजह से क्या होता है कि हम लोग को मोलर कंडक्टिविटी को कंसिडर करना पड़ता है फॉर दिस what electrolytic conductors. We cannot just talk about the conductivity, we have to take into consideration the volume, the concentration, right. Concentration को तो लेना पड़ेगा क्योंकि we are dissolving this electrolyte in some kind of solvent, and hence what will happen, the concentration has to come into consideration. Hence this term is defined, which is the molar conductivity, or one more is there, equivalent conductivity, but in your syllabus there is only the molar conductivity. Okay, now this molar conductivity, what is the definition, we will see. So it is the conductance, it is the conductance of all the ions produced by 1 gram mole of the electrolyte in solution. Okay, so देखो स्टूडेंट्स, अगर यहाँ पे जो मैंने बोला, इस जगह में ना, इस जगह में अगर इलेक्ट्रोलाइट का जो अमाउंट है इसको अगर तुम फिक्स कर दो, बिकॉज हियर तो मैंने कोई बात नहीं किया, सिर्फ बोला 1 ml लेना पड़ेगा, लेकिन अगर तुम 1 मोल, here if you take 1 mole of electrolyte, say if you are taking KCl, अगर 1 mole KCl लेते हो, ठीक है, 1 mole अगर KCl लेते हो, and then you find the conductance or the conductivity, it will be termed as molar conductivity. So molar conductivity, it is the conductance of all the ions produced by 1 gram mole of the electrolyte in solution. That means if you take 1 gram mole, that means 1 mole of the electrolyte here, and you find out the conductivity, the conductivity will be called as the molar conductivity. Simple, 1 mole इलेक्ट्रोलाइट लेने से जो कंडक्टिविटी प्रोड्यूस होता है, जो कंडक्टिविटी मिलता है, इसको ही हम लोग क्या बोलते हैं, molar conductivity. Okay, and how can we measure molar conductivity? So molar conductivity cannot be measured directly. Okay, it cannot be measured directly. So what do? We find out it in terms of the conductivity. Molar conductivity जो है वो directly we cannot find out, ठीक है, so that's why we find out the molar conductivity in terms of specific conductivity, right? So molar conductivity को हम लोग represent करते हैं lambda m से. This symbol is lambda. Okay, this symbol is lambda. So lambda suffix m. So we represent molar conductivity like this. It is equal to conductivity. This is the specific conductivity, right? Conductance of 1 centimeter cube of the electrolyte, right? It is the specific conductance, and this is what? This is the concentration. And since we are talking about the molar conductivity, the concentration is what? Molarity, in molarity. So here in case of molar conductivity, the concentration we take in molarity, because already I have said you that when we talk about the what, when we talk about the electrolyte, the concentration has to come into picture. ठीक है, एक्चुअली क्या होता है, करंट जो आयंस से कैरी होता है इलेक्ट्रोलाइटिक कंडक्टर में, करंट इज कैरिड बाय द आयंस, एंड द आयंस का जो कंडक्टिंग पावर है, इट डिपेंड्स अपॉन द नंबर ऑफ आयंस पर यूनिट वॉल्यूम ऑफ द इलेक्ट्रोलाइट. ठीक है, जो आयंस है ये उस वॉल्यूम में, मैंने पर यूनिट 1 जो सेंटीमीटर क्यूब वॉल्यूम है, इसमें कितना कंडक्ट, मैंने उसका कंडक्टिविटी पावर इसके ऊपर डिपेंड करेगा कि यस, सो इट विल डिपेंड अपॉन द कितना नंबर ऑफ आयंस है. ठीक है, पर यूनिट वॉल्यूम में या 1 सेंटीमीटर क्यूब वॉल्यूम में कितना नंबर ऑफ आयंस है, इसके ऊपर तुम्हारा क्या होगा, द कंडक्टिंग पावर of the electrolytic substances, it depends. That's why we have to define this term. So we have to write this concentration term. ठीक है, पहले तो ये नहीं आया, लेकिन मोलर कंडक्टिविटी में ऑलरेडी मैंने बोला वॉल्यूम कंसिडरेशन में आएगा, क्योंकि आयंस को तुम किसी में डिसॉल्व करोगे ना. So that's why we have to take into consideration this molarity. Okay, this C is nothing but molarity, and if it is given in mole per liter, because molarity will be mole per liter, so no problem. But if it will be not be given in like this, it will be given at in say mole per liter, mole per ml. What you will do, you will write like this then. So अगर मोल पर लीटर में दिया हुआ है क्वेश्चन में, बिकॉज वी विल डू क्वेश्चन बेस्ड अपॉन दिस, सो अगर मोल पर लीटर में दिया हुआ है वॉल्यूम तो कोई प्रॉब्लम नहीं है, लेकिन अगर ml में दिया हुआ है देन यू हैव टू डिवाइड इट बाई 1000. सो अनदर एक्सप्रेशन यू गेट नाउ which is the lambda m equal to k into kappa into 1000 by c. Okay, so where if it is given in mole per liter, the volume is given in liter, no problem, but if it is not given in liter, this expression you have to use. Okay, so this was all about the molar conductivity. So yes, so we will in the next lesson we will do about the numericals based upon these molar conductivity. Okay, it is very important, it comes, and some more topics are there left, okay, related to all these topic, but this was all about just introduction to this topic. So I hope that you found this video is useful, right? अगर ये वीडियो अच्छा लगा, यस, एक चीज़ भूल रही हूँ, यूनिट, यूनिट इसका बहुत इंपॉर्टेंट है। यूनिट क्या होगा देखो, कप्पा का यूनिट क्या होता है, कप्पा का यूनिट वी हैव टेकन आउट साइमन पर सेंटीमीटर, ठीक है ना, साइमन पर सेंटीमीटर, ठीक है, यहाँ से निकाल रही हूँ, ठीक है। लेमडा एम का अगर यूनिट निकालना है तो कप्पा का यूनिट डालो यहाँ पे साइमन पर सेंटीमीटर, और कंसंट्रेशन का यूनिट क्या होता है, मोल पर लीटर, है ना, मोल पर लीटर होता है, या मोल पर ml होगा, तो ml वी राइट इन सेंटीमीटर लाइक दिस। सो क्या होगा इससे, साइमन -1 + 3 एंड मोल इनवर्स, सो साइमन, so it will be Simon mole inverse centimeter square. So this is the unit of lambda m. This is the unit of molar conductivity. So unit is also important, remember. Okay, so here this is the end of these very some topics, right? So अगर ये वीडियो यूजफुल लगा, प्लीज़ शेयर दिस वीडियो विथ योर फ्रेंड्स, ठीक है, शेयर करिए अपने फ्रेंड्स के साथ, और चैनल को प्लीज़ सब्सक्राइब करिए और बेल आइकॉन को भी प्रेस करिए, ताकि जो नेक्स्ट वीडियो मैं बनाऊँ या सो यू विल गेट द नोटिफिकेशन ऑफ दैट, ओके। एंड like the video, if you found this video useful, you like it, share it, and please subscribe the channel. So thank you so much.